The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everyone. Thank you for joining our webinar today. I'm going to talk about a very niche topic, which is the mobility simulation. And I'm going to touch upon also the traffic mobility simulation capabilities inside of InfraWorks. So let's get started. Okay, so before we start, we're going to show you some polls, and we would like to request your feedback on them, please. Okay, so the first one, I would like to know from you, how often do you use Autodesk InfraWorks software in your organization or for your current or previous projects? Is it all the time? Is it most of the time? Rarely or never ever you have ever used the software? Okay, so I'm just gonna give you 5 more seconds so that everybody will have the chance to pick an answer. Okay. Okay, perfect. Thank you very much. The second poll question is actually, did you make use of the InfraWorks traffic simulation or mobility simulation before in any of your projects? Is it yes, many times, yes, maybe few times, or no, never? So here we're discussing both. We do have 2 types of simulations inside of InfraWorks. I'm going to touch upon both. We have the traffic simulation and we have mobility simulation. Have you ever used any of those capabilities? Okay. Okay, perfect. Thank you very much. Okay, then the third one is, how many online resources do you already know about and you use basically to learn more about the Autodesk software? Do you know more than over 10 sites, 5 to 10 sites, 1 to 5 sites, or none? It could be about best workflows, maybe tips and clicks, or latest features as per the latest software releases. It could be video websites, I don't know. Okay, thank you. And the last poll for today's webinar, I would like to know from you, please, what is your role in the project that you're currently running or within your organization? Are you a civil engineer, a traffic engineer, an architect, a master or urban planner, or something else? Okay, so answers are coming in. Okay, perfect. Thank you very much. So now we're ready to go. So I'll start by showing you the agenda for today's webinar. Since most of you are not traffic engineers, I'll start by having... Okay. If you guys are not seeing my screen or you have any issues with the audio, please let me know using the chat box. Okay, so currently I'm showing the slide for the agenda of today's webinar. I'm gonna start by talking about the definitions in the industry. Then I'll move into the reasons why we do need to simulate traffic or pedestrians or even passengers throughout the transportation systems. Then I'll talk about the InfraWorks simulation capabilities, and here I will highlight what I have already covered before in one of my webinars regarding traffic simulation, very briefly, and then how we can leverage the mobility simulation capabilities as well. Directly afterwards, I'll talk about the traffic simulation as an overview. What are the major features? Where do we use it? And why do we need InfraWorks mobility simulation? So I'm going to show you an actual case study from San Andres Airport. I'm going to show also other use cases. There are many of them, but I've just collected like maybe 7 or 8, the major use cases worldwide. And then I'm going to talk about why do we need sustainability. So we hear a lot about smart cities and sustainability and how we can leverage such a tool from Autodesk to have more sustainable infrastructure or transportation systems. Okay, so first, terms and definitions. I would like to talk about traffic simulation. So as per Wikipedia, traffic simulation is basically a mathematical modeling of transportation systems. These might include freeway junctions, arterial routes, roundabouts, downtown grid systems, and many others. And the objective out of that is to plan, design, and operate those transportational systems. The simulation of transportation systems started a long way back, over 40 years ago, and it's a very important area of discipline in traffic engineering and transportation planning today. The simulation in transportation is important because it allows us as engineers or as consultants to study models that are too complicated for analytical or numerical treatment manually. And it also helps us produce very attractive visual demonstrations of present and future scenarios. Hence, we know how to design our projects or expand them further. For traffic analysis on the other side, or mobility analysis in civil engineering, it's basically studying the interaction between vehicles, drivers, pedestrians, cyclists, and other travelers and infrastructure objects. So anything basically that moves within our system or structures is basically part of the system analysis. So things like highways, signage, and traffic control devices. The aim of having that analysis is the understanding and being able to develop an optimal road network with efficient movement of traffic and minimal traffic congestion problems. So these are just top definitions for these two items. Now, before we talk about the software and how to handle things and make use of it, we need to understand the travel model. So in any travel model, we have zones and we have areas. I'm going to talk about both, but let's think of people moving around our transportational systems as demand. So these people demand certain level of service. They demand that they're able to move from point A to point B, etc., etc. And then the supply basically are the vehicles or means of transportation, like walking, like taking a taxi, a bus, etc., etc. What we're doing with InfraWorks or tools like the mobility simulation within InfraWorks is basically being able to model the journey from an area A, where people will take some sort of transportation, to area B. And the way we do it, we specify an area A. That area basically connects to zone, let's say 1. That zone connects to zone 2. And then from that zone, we go to area B. A simple example would be a passenger going from, let's say, home to a bus station, taking the bus to the other bus station, and then walking towards campus or the place of work. As simple as that. What I want you to get from this demonstration is that the term area is used for people and the term zone is used for vehicles. So why do we need to simulate? In many cities, private car travel is the dominant mode, right? But that actually creates a problem because population is ever growing. We have more cars on the road and we have more traffic congestion problems worldwide in many, many cities and capitals. Hence, we as engineers are usually tasked to solve this problem. The easiest problem is just create new roads, right? We create new roads, or we basically add new lanes to existing roads, etc., etc. That's the easy way out. But we already know that in many cities worldwide, we're running out of space. This is why we need to have traffic simulation, mobility simulation algorithms to help us understand how we can optimize the performance of those existing systems. So basically, urban mobility considers how people, not just vehicles, people get to where they want to be using different modes, multiple modes of transportation, like a car, like bus, like train, like walking, taxis, cycling, and others. And by the way, many large and high growth companies worldwide now have research centers and have a very detailed plans and focus on urban mobility. Just want to mention some of them like Uber, Lyft, Tesla, Google, and Apple. So this is really a very important area of study and research. So how can we answer such questions? For instance, we are going to build a new bridge across the river. How many lanes do we need to have on that bridge and the off-ramps? Do we take it for the existing demand or existing requirements of traffic, or do we, for example, plan it for 10, 20, or 30 years? If we have a 4-lane road, main road demand is X, and the oncoming demand is Y, and there is a left turn proportion of T percentage. Should we have a 1, 1.5, 2, or 3 left turn lanes? Another instance, if I have a 4-lane road with X, Y, and T as above, but there is room for only 1 left turn lane, what is the best cycle or split time for the intersection? How do we time, for example, the traffic signals in there to optimize the movement of traffic and reduce the congestion and the queue length and the queue delay? All of these questions can be answered using the traffic and mobility capabilities within InfraWorks. And by the way, usually within any infrastructure project workflow, we start by planning the project. So we leverage InfraWorks to do things like identifying the need early on. We propose designs, so InfraWorks allows us to come up with option A, option B, and option C, what we call as optioneering. Then we analyze those designs. After analysis and validating them, we basically select the best design option to take it further into detailed design. A very simple diagram would show us we have design A, costs us this much, has this benefits, the same for B, same for C. How do we basically analyze those benefits and quantify them? By using tools like traffic mobility simulation and InfraWorks. And once we're done, we move that best selected design to AutoCAD Civil 3D and other tools down the line. Now, most of the transportational systems worldwide get decided upon using this cost to benefit ratio. So we analyze what is the cost of constructing or implementing a transportation system of upstream bridge, downstream bridge, maybe creating a tunnel. And as you can see, for example, constructing a tunnel costs a lot more. So we have the cost in there. We get the benefit, which we can use or we can get as a byproduct from using the traffic and mobility simulations. And then we just have the benefit to cost ratio. We pick the one that has the highest best benefit to cost ratio to push it forward for detailed design. And how do we actually estimate those benefits? These benefits might be things like time saved on the way from work to home, or from home to university, or the study place, etc., etc. So we quantify that in terms of money value or time saved. We have distance saved as well, because that translates into less fuel being consumed, less maintenance for the cars, and definitely less cost. Things like stops saved. So also fewer stops mean less fuel, less maintenance, etc., etc. So this means smoother ride from point A to point B. All of these and many others are being calculated to get the total benefits of having a certain design option for an infrastructure or transportation project. But then we also have to take into account the lower emissions and having a greener impact, a greener project and less impact on the environment. So all these add together to finalize the benefit of any project. Now for transportation modeling, we need to maximize the benefit and minimize the cost. And by the way, transportation modeling is defined as the process of estimating the benefit measured by metrics like, so the metrics are usually like things like delay, the flow, the stops, the queue length, the fuel usage, and many, or a combination of many other factors. Most of which we can check using the simulation tools inside of InfraWorks. Now, in the industry of traffic modeling, for those who are new to this domain, we do have 2 or 3 major ways of calculating the traffic and checking for delays. There is the deterministic method, which is very simple, using simple equations with inputs and outputs. And the typical use case for such a method is usually estimate the capacity from geometry directly for simple scenarios, like one simple intersection, one simple roundabout, basically one bottleneck in the system. For instance, we have 3 lanes, we have a width of 9 meters, we have a control that's basically yield, maybe not signal, and then we have a capacity that is static of 5,800 vehicles per hour. We don't have any variation whatsoever throughout the hours of the day. And then by using simple calculations, we basically calculate what is the expected delay and the peak flow at that point in time for this existing system. The more advanced way of doing it, and this is why most of the available software or tools in the market do, is what we call stochastic determining methods. And here we not only have a specific number or a specific geometry or a specific flow or number of vehicles per hour, but rather we have a range of inputs. So this meaning we deliver a range of results as well. We use simple mathematics and a set of rules to approximate a complex system, yes, but the input is actually what matters. This means vehicles move through a network adhering to a car following and gap acceptance method, which we as traffic engineers or designers, we set into the system. Now, it's worth mentioning that InfraWorks traffic mobility simulation capabilities, and by the way, they used to be known as Commuter. This is the technology that Autodesk acquired before integrating with InfraWorks, uses something that is called car following, lane changing, and gap acceptance algorithms that are updated several times every second, which provide the basis for calculating delays, and it's called a micro-simulation method. Micro-simulation in the sense that each and every car, each and every vehicle, each and every pedestrian is considered a separate entity that has specific parameters. Let me take, for instance, a driver. So one driver can be considered a very smooth driver, keeping a long safety distance between his vehicle and the other vehicle. The other driver might be aggressive, might keep a safety distance of maybe less than 2 meters. All of these can be input in the system, and we can analyze each and every driver, each and every pedestrian throughout. This is why we call it micro-simulation. And just to give you an idea, why do we need stochastic methods and micro-simulation is shown in these 2 graphs. So throughout the week, for instance, you can see here the graphs, Monday, Tuesday, Wednesday, etc. We have a specific demand. This is representing demand of, let's say, 500 vehicles per hour during a certain hour throughout the day. Using those parameters, different properties for each and every vehicle or pedestrian, we get an average delay of around, let's say, 10 seconds on that day. Whereas if we change some of the parameters, this basically drops to, for example, like 8 seconds of average delay. And the same goes for the other days as well. Hence, we have a different mean or different average of delay based on the properties and not just the numbers that we have for the flow or number of vehicles passing per hour, giving us more insight how the project will perform over time and based on different parameters. Okay, so that's enough about the principles and the theory. Let's talk about InfraWorks and what InfraWorks can bring to the table. We have traffic simulation and we have mobility simulation engines inside of InfraWorks. So once you open your InfraWorks software and once you go into the road module, which is over here, you have to go into the analysis tab, and under which you will have fly out icons that basically have a traffic simulation icon and a mobility simulation icon. Okay, the traffic simulation capability basically allow you to simulate and analyze the movement of private vehicles only, meaning cars and trucks, and in some instances just crosswalks, simple crosswalks, pedestrian crossings. It basically does that using the cloud, does the simulation in the cloud, and then pushes it to your machine, animates the InfraWorks model in Canvas, and the delay and queue results are shown also in Canvas as well. I'm going to show you examples later on. On the other side, mobility simulation allows you to analyze and simulate the movement of all possible vehicles and pedestrians. This including cars, trucks, buses, trains, and taxis as well. So we basically simulate pedestrians and cyclists. And by the way, that simulation is being done on the desktop itself. So it's desktop centric. Mobility simulation is a separate desktop tool, and the mobility simulation is basically launched from within InfraWorks, but does not send the results back to InfraWorks. I'm gonna tell you what does that mean in a second. Just to summarize the differences between the two, so you have vehicles here, just private vehicles. You have all types of vehicles and people moving around. The level of analysis is basically neighborhood to a small city scale level for both because they use the same engine in the back end. The animation, however, it's done in the InfraWorks model. So whatever you create in the traffic simulation tool, you will see it in 3D in your InfraWorks model itself. However, for mobility simulation, everything that you simulate or you animate, you will only see it in the specific mobility simulation panel, but won't be pushed back into the InfraWorks model. They both actually export reporting into different file formats. They show the delay and the queue length. They show the mobility simulation on the other side shows a lot of more delays and metrics for us to understand. The release date, this was released with the InfraWorks June 2016 release. This was released in 2017.1 release. And as I mentioned earlier, this one is cloud-based. This one is local on desktop. Now, I want to mention that if you want to run traffic simulation and have those animations shown in the InfraWorks model, it's actually going to request you to have some cloud credits. So if you want to simulate a model that is around 1 square kilometer for 1 hour, this is gonna request 1 cloud credit in terms of consumption. If you have 2 square kilometers, you multiply that by 2, becomes 2 cloud credits. If you have 2 square kilometers for 2 hours, then you multiply 2 by 2, and then you get 4 cloud credits required to run that simulation. However, mobility simulation is free of charge because it's not gonna push that into the InfraWorks model itself. Okay, why use traffic simulation? We use traffic simulation capabilities inside of InfraWorks for 2 different project phases. We use them for the pre-construction phase, whenever we are planning and designing a certain road, highway, or even intersection. And we definitely use them also for post-construction stages. So whenever we have an existing network, how do we leverage those simulation capabilities to check where are the possible bottlenecks? What if the demand increases and there is a huge increase in population or number of cars on the network? Things like that. What if we have a construction project going on and 1 or 2 or more lanes will be obstructed or closed for construction vehicles? It also helps us to visualize and communicate the design very quickly and very easily, and showing definitely the benefits of that design. So I'm going to show you a short video which basically shows you the existing conditions right now, and we have a lot of traffic. We can check the traffic queue lengths and delays from the model as well. We can see what are the proposed conditions after we, for example, add a turning or additional lane. And we can see also the process throughout the construction phase in 3D. Typical users for the traffic simulation and mobility simulations are definitely the consulting firms like AECOM, Jacobs, Parsons, and many others, and definitely many of the other smaller firms who are really specialized in traffic and mobility studies. The typical end users, as you would expect, they're usually the governmental entities, the departments of transportation in the US, probably municipalities, any governmental department or entity that has to do with the traffic and the levels of service. So the traffic simulation, as you can see from this model, is very simple. So we can rely on the software to do the simulation for us, or else if we have the traffic demand, which is more accurate data, we can plug it into the system and then run the simulation to see the average delay and the average queue length at any bottleneck, whether it's an intersection or a roundabout, for instance. And then on the fly, because it's a BIM 3D model, we can click on that intersection and modify it. For instance, add an additional lane, specify the timing of that intersection if we have a traffic signal, or just maybe place a yield signal and let the traffic take it on its own. So in this case, we added one lane. We ran the simulation again based on the same traffic demand, and we figured out that this bottleneck has been resolved. We have a shorter queue and a shorter delay for the traffic, meaning the level of service now is green or blue, depending on the level of service we have, and it's compliant with the requirements of the level of service. Okay. The other part, or the other way of using the traffic simulation, is basically throughout the construction process. So we have an existing network, and as you can see, vehicles are moving around freely. Maybe the levels of service are okay, but we can check. So we can check per lane, we can check per approach. And let's suppose there is a construction project that's going to take place over here, and maybe one of the lanes will be obstructed or closed for traffic. So we can directly see the impact of that construction project on the existing traffic. We have too many red cubes over there, which means the levels of service are not maintained. So what if we change the timing of the intersection? So we give, for instance, let me move a little bit here. So yeah, we just change the timing of the intersection to give more priority to some approaches or some lanes. We run the simulation again, and we find out that this basically solves the problem. So there is no need for us to add additional lanes or have additional investment. Just a small modification of the traffic controller for the signals, and the problem will be resolved. And by the way, transport modeling itself is a well-defined process. There are many manuals, many systems to manage the modeling and the analysis of transport. I just want to mention, for example, the New South Wales in Australia. We have the London manual, and we have definitely the Federal Highway Association in the US. Luckily, the commuter engine, which is basically the technology backing the traffic and mobility simulation side of InfraWorks, is already approved in many of those manuals, like the one coming from Australia or New Zealand. Definitely like others as well. Okay, so whenever we talk about traffic modeling, we have different tiers or different levels of complexity. The InfraWorks traffic and mobility simulation is basically catered for the smaller ones, like a local area network. And by the way, this is from the London, the UK transport manual. So you can see the local area network over here. We do cover it by InfraWorks. The micro simulation model as well, which includes maybe up to 50 different intersections or roundabout 50 to 75 max. And then we have the area model, what is called the area model. So we touch on that area model as well, but we cannot cover a huge area of over, let's say, 75 different bottlenecks. There are other tools available in the market to do so, like Vism, for instance, and there's definitely the larger area or strategic model for the whole city with its neighborhoods that can be simulated in other tools available in the market. So our focus for InfraWorks are these three areas only. What we call the neighborhood up to the city scale model, in fact. Okay, so we talked about traffic simulation, we talked about the theory behind it. Now let's move into mobility simulation in particular. As I mentioned, the computer engine is the one driving all the simulation, the calculation, and analysis in the back end. What you see from this video is are different cases of using the mobility simulation, of checking, for example, a pedestrian going from point A to point B using multiple or multi-modal systems, using a car, a taxi, a bike, a train station, checking through security gates, etc., etc. So all of that can be captured in one single InfraWorks mobility model. And as you can see, while we're doing the simulation, we do have direct feedback about the steps made, about the time required to move from point A to point B to point C, and even we can estimate the cost of that movement or that travel, because we do have key performance indicators. So why do we use this? We use the InfraWorks mobility simulation to design and check things like the queues, to compute the number of security agents at peak hours in airports and other places, to optimize the space, and definitely check for the levels of service, not only for vehicles, but also for pedestrians or people moving around. It also helps us a lot in justifying investments. So if we want to add existing lanes, if we want to add existing security agents, if we want to, for example, create more space for people to gather in, or even maybe extend the scale of a train station, all of that can be justified by running a simulation and analyzing the results using this tool. It helps us, as I mentioned, in the platform design for train and subway station to size them properly. It also helps us in automatically computing the optimized time for the subway doors to remain open at peak hours, or for the optimized time of the traffic signals on any intersection. And definitely optimize the time spacing between trains. So even for train stations, the time required between each and every train can be optimized to cater for the level of service at that particular train station. And we can definitely model more than one train station within a same model, and then run the whole analysis for all of them at once. These videos are just examples of many of the case studies and the projects worldwide. So the one at the top is the Stanley Hospital model. The one to the right is basically for a parking layout, because we do also satisfy the parking requirements and analysis. The one to the bottom is a city model with too many intersections and shared zones. And the one to the right is a very similar case as well. So you can see we have the interactions of vehicles. If I move a little bit forward, how these vehicles are queuing at any intersection in 3D. Then people, for example, get to a station or a place where they need to tag their cards and move into the platforms, take different sorts of transport. On the right, we have a parking layout, people moving in, parking their cars, and then getting out of their cars, moving to, for example, a shopping mall or a certain interesting destination. On the bottom left corner, we have a city model with parking bays parallel to the road, with taxis as well, so we can simulate people getting to the taxi, riding the taxi, and moving from point A to point B, etc., etc. So many use cases are available. And the good thing about this mobility simulation tool, that inside the tool itself, there is a huge manual, including all the things that can be simulated, how to simulate and analyze them, and what are the steps required to basically create a model. So you'll find too many different articles and documentation on how to use mobility simulation, why to use it, and the expected outcomes out of it. Now I'm going to share with you a real case study from Colombia. It's using the mobility simulation tool in particular for the San Andres Island airports. Okay, So this is just a quick video showing that they usually have a lot of passengers traveling in airports, and airports are actually having a lot of problems nowadays optimizing the flow of passengers and airplanes. So you can see a lot of problems in there. It has been highlighted in the news so many times. And then they had this issue of the San Andres Island. It's a very small island over here in the Caribbean Sea, where the island has only one airport. That airport is very small and cannot basically serve the passengers. This is a snapshot of the island. This is basically a layout or a plan drawing for the airport in San Andres. And this is actually what was used to model the mobility simulation model inside of InfraWorks. So no CAD, no Revit model whatsoever. We just took, or my colleague actually from the US, his name is Edmundo, took that as the plan or the layout, and then he started tracing where are the international arrivals terminal, where are the control gates for the passport control, where is the city control, the national arrivals, because this airport basically serves both international and national arrivals and other things as well. He took also the data from the airport traffic controller about how many airplanes get there at what time and how many passengers are on each and every plane, depending on the plane size, plane details. And then he basically simulated that in InfraWorks. These are just some pictures from the chaos that happened in there because they had some emergency. People were actually waiting so much time to get to their airplanes. Even in the airport terminal itself was a huge mess. As you can see, so many airplanes basically have no place to get to the terminal, so they were just going around. And even the traffic controller shared a video of how the traffic was diverted or asked to go around the airport terminal in the air for so much time, not being able to land and basically get the passengers to the terminal. So let's directly show you. This is the San Andres Island, modeled all together inside of InfraWorks. And for those of you who never used InfraWorks before, we can directly create those models easily using the model builder functionality and up to a scale of 200 square kilometers. But if you do have more data, like for instance, you have an area of 1,000, 2,000 square kilometers, you can still model that very easily inside of InfraWorks. It's a very, very powerful platform that can support huge city scale models. This is another screenshot of the model showing the simple layout of the airport. And then we can run into the simulation. So let me just open the software very quick and show you. So, okay, I'm gonna go one step back. This is the InfraWorks homepage. So you do have access to all of your models. I'm gonna just delete that. All of the models that you created are gonna show up with thumbnails. Once you hover over the model, you'll be able to see some more details. So I'm gonna type in order to search and find my model. That's the one. I click on it and there you go. So I'm gonna zoom out a little bit and show you that this is the whole island modeled inside of InfraWorks. I can zoom in, I can see where are the existing, for example, buildings. I can see the existing road network, etc., etc. And to make things easy, I've created a bookmark. Once I click on that bookmark, it takes me directly into the model of the airport. Okay, so what do we need to do here? And I'm not gonna cover it in detail. Basically using the road module, we click on the simulation tab. And here we just click on mobility simulation. What I did early on is select an area of interest and inputted all the requirements and detail. What I will do right now, just to show you some of the capabilities of the system, is right-click on that area and then pick Mobility Simulation Engine. Once I do that, it's going to fire the Mobility Simulation panel in the back end, which is a separate instance of the InfraWorks model. And as you can see, I do have some roads and intersections, but this is not what I care about. I'm going to open very quickly one of the models created for that airport. So it's saved as an AZA file because this technology was acquired from a Zalian company. Okay, this is a simple representation of the international arrivals. For instance, people arriving at the airport, queuing or gathering here, and then coming into the queues before going into security control or screening, and then making the way to the baggage claim. To the right of the screen, we have too many tabs. This one basically shows me a list of all the simulations created, different timings, different demands, etc., etc. We have the analysis tab, the actions, the layer where I can turn things on and off to show them in the model. For instance, I have here a very basic model without a texture underneath, without any visualization perspective. And definitely here what we want to see in the model. Now, to the top left of the screen, you have all the things that you can do. You can specify parameters like terms, behaviors, type of vehicles, and how do they react within a certain model, the types of people with different parameters as well, and many other objects also. The network, we can specify trails, services, stands. We can control the intersections. We can control boom gates. Demands, this is where we create the divisions based on a certain time frame. What is the variability of traffic or pedestrians throughout that demand? We can pick the demands from here, specify. As you can see, it's basically a matrix. And this matrix, we can directly copy paste if we have the matrix in Excel or PDF, just copy paste this data into the matrix and run the simulation. I'm just going to keep this for now, assuming that we have 160 passengers arriving at that terminal per hour. And just to show you really quick how the simulation happens, I'm going to pick one of the simulations in here, which I created earlier. I'm going to highlight it. This is the one I want to show in my canvas or model. Click the play button, and then you will see passengers coming into the security gates and queuing. If I want to make it faster, I can click the faster button. I can make it even faster, and then see if people are going to queue or not, or if this queue length is enough for me or not. Now, this is expecting 160 passengers per hour, which is not much. We already know that most aircrafts nowadays support more than 250 to 300 and even more passengers alone. So what if I come here to the demand tab, I pick the demand matrix, and instead I'm going to put some theoretical figure like, for instance, 1,000 passengers per hour, which is like 3 aircrafts per hour. I'm going to save it, and then I'm going to ask it to run the same simulation again. Okay, I'm going to make it a little bit faster. And then you see how people start to queue in here, right? So we start to see that we're starting to have problem in real time. I definitely can export this data in terms of time and see how much time I need before we have all the queues completely filled with passengers and even people blocking other entrances or gates from the other side. So it's a very direct visualization on how things happen at InfraWorks or within our model. So this is basically the model I showed you earlier. Let me see if I missed anything else. Yeah, so we see people moving in, moving out. That's fine, covered. Okay. So as you can see, people are moving in and moving out. This is just an example that we can actually create some lanes for people to pass on, even if there are escalators or elevators in the process, and simulate that as well. We can have also some visualization on what are the preferred routes that people will take based on certain criteria, where is going to be the most delay, and highlight it in different colors or different themes throughout the model. Okay, so as you can see, for example, we do have visualizations of people themselves. We have people in yellow, people in violet color, and that all depends on the type of people and maybe even on the time of arrival and delay they will encounter. Here, we're just showing you the example that my colleague Edmundo worked on. He basically modeled, so he took that layout, which is even not 2D, just plain raster image, placed it to scale, and then created the international terminal and the local one in one single model, and shown the interaction between the two towards the very end in here. So it's just simulating the passengers from one side and simulating the passengers also from the other side at the same time. And you can definitely see the interaction between the two. Okay, what are some of the other use cases for mobility simulation? So let's talk about the other ones. We definitely support parking lots, indoors and outdoors, inside of buildings, intersections, roundabouts and interchanges, roads with pedestrian crossings, and buses and taxi stops and parks and resorts. Let's see some of these in action. So intersections and roundabouts, like we do with traffic simulation, we can do in mobility simulation as well. So you see here, maybe a city scale model with too many different intersections and roundabouts. We can simulate all that in one single shot. So I'm just gonna move forward. We can specify the passes in here for each and every intersection. We can specify, for instance, the allowed movement of traffic. So this lane, for instance, can take the left turn and can go forward, or just can take the left turn. So we specify all those in ahead of time. We can specify even all the permissions in one single matrix, as you can see. We can also add the timing of the green and red and amber signals for each and every approach of each of the signals in there. We have the representation of the traffic controllers. So you can basically configure everything as if you're gonna push that, and you can push it to a traffic controller module that basically will run the whole traffic signaling on that intersection. So as you can see, we have all of them in here. The phases, the timings, the permissions for each and every lane or each and every approach. And you can run the simulation inside of the mobility tool itself in 2D or 3D. And in real time, you're gonna see the effect on the occupancy, the delay, the queues, etc., etc. Any modification to the parameters will result in a new and updated simulation. Okay, what about campus walkways or walkways within a space like airports, convention centers, or universities? As you can see, this is a very simple way of creating pathways. So we have one, we have two, we can modify them, we can extend, then we select whatever we have as a pathway. We can specify also permissions if there is any object in between, and let the people go around it. This is just a sample walkway model, and what we're gonna do here is just specify that the middle or the center of that walkway will be obstructed by an object or a construction job taking place. So you will see how people are basically going around that box and not moving into it. And this will also help us understand what is the delay, what is the impact on that model once that construction job is in place. Pedestrian crossings. So we all have pedestrian crossings in our cities, and these have either signalized or other forms of control. In this case, it's a signalized crossing. We open the relevant model for it, and then we can start basically modeling that crossing in 3D. So we have 1, 2, 3, 4, 5, and then you can see that whenever the signal is green, pedestrians are allowed to move and cross the street. Whenever it's red, pedestrians are not allowed. They will just queue at the signal and then cross the street. By signalized, we mean there is a button for pedestrians to press on to turn the signal from red to green and allow them to cross the street. And that all can be simulated and analyzed in the software and check what is the level of service for both the vehicles at that crossing and for the pedestrians themselves. What about the zebra intersection? Basically, yield or giveaway. So whenever the pedestrian approaches, the vehicles will stop. Whenever there are no pedestrians, the vehicles will continue their normal movement. So in some instances, the zebra movement, the zebra intersection or crossing will be a more efficient option. The controlled or signalized crossing will be better in certain situations. And the tool will allow us basically, as I mentioned earlier, to pick or analyze option A versus option B based on the metrics and numerical figures extracted from the model. What if we have a crowded city and we have some shared zones where people and cars share the same space? So we see these in many cities worldwide. You can also model that in the same model and see how do these objects interact with one another. We can also simulate and analyze moving people around vehicles, moving people around buildings, inside buildings like museums, schools, universities, and airports. So depending on a certain layout, how much time does it take them to move from point A to point B, from floor 1 to floor 5, using a single route or multiple routes as necessary. We also support simulating elevators in buildings, but this is, just to be clear on it, supports only the basic algorithms of elevators. We now know that there are smart elevators, so you have those new towers coming up, where they have, for example, 6, 7, or 8 towers, 6, 7, 8 elevators, and these elevators talk to one another. So if one elevator is empty, will go down. If the other one is fully occupied, it will not basically go to the required floor. So that sort of interaction or smartness is not supported, but the basic one is definitely supported in the tool. We also support escalators in buildings, such stations, hotels, and other places as well. And the cool thing about escalators here that are very detailed to the level where I'm just going to save you some time and move to the towards the end of it. So as you can see, people are moving up and down. But what's really interesting is that it also supports the movement of people. Sorry, I moved one step further, so it's over here. So as you can see, we can support or analyze 2 levels of people going up or going down. So we have the first row and we have the second row. So people at the right might have a certain speed, maybe they're just standing there, whereas people to the left are basically moving or hopping on top of the steps to go upstairs at a faster pace. We can simulate both and check what is the throughput or the level of service at escalators as well. We also support the transit lines along roads for bus stops. So here we're just showing you how to create an area where people basically will gather or will stay to take a certain bus stop. So we're moving from this bus stop to the other bus stop across some roads and intersections throughout the city. And again, as we've seen before, we can model all that in 3D. We can see the signals, we can see people getting into the bus. That bus is driving through the prescribed route and then moving to the other station. We can even model the station, the bus station itself. Do we need more space to accommodate more passengers or not? And we also have the numerical figures to help us see what is the right time, what is the drive time, the cycle time, etc., within that model. Do we need to improve it, or is it already okay? Another case study is basically the rail stations. So as you can see from this model, we have a complex rail station of multi levels. So we have the top level, which basically have the trains stopping. We have the people moving in, checking in, and then moving up using the escalators, waiting for the trains to arrive, and then getting on those trains altogether. And definitely all with having the numerical data to support with the analysis. Parking lots, so it will take into account parallel parking, oblique parking at a certain angle for a certain structure at a certain floor. And same story, we can simulate those vehicles moving in, moving out. Where do people park their cars? Do they move to the other side, take the pedestrian crossing, and how all that will fit into a model, and how would the vehicles and pedestrians interact and affect each other. So this is basically what the tool can support you with in terms of analysis and simulation. But let's take a step back. What about sustainability? So we all know, and we all believe actually, that public transport is actually very effective, right? And using our private vehicles like a truck or an SUV or a motorbike is not that energy efficient. But what if in reality we have things like that? We have metros or trains that are not utilized, or buses, in cases where people basically make best use out of those trucks or private, means of transportation. So which one now is good, which one is bad, which one is more energy efficient? So in order to avoid such situations, we need to have tools like mobility simulation to analyze and make sure they're utilized to the utmost situation. In that sense, I want to mention that the tool itself can provide us with so many performance indicators, like the ones that you see here, extracted directly from the model as CSV, Excel files, or even JSON files. And we can extract information like the person hours traveled, the person's kilometers traveled, the vehicle's kilometers traveled, the vehicle's hours traveled. So we're talking about persons, we're talking about vehicles, time and distance. We have multi-modal level of service calculations for both, and we have the economic and environmental assessments. So we can add a unit cost for each and every pedestrian and moving object, and then we can analyze the total cost of moving from point A to point B, or the infrastructure involved. So we're not just relying on visualization in 3D or simulation, but also we can get very accurate data that we can leverage in our analysis. So the assessment of that goes in like that. We have option 1, drive to the park, take a car. Option 2 would be drive, then take the train, move across the city. And how this actually happens inside of the tool is we are micro-simulating each and every step. So we take the car, we take the train, how much time is being involved, it's accumulated, what is the distance, and what is the total cost of moving of that passenger. This is how the system is doing it, step by step, throughout time. And reporting of results, as you can see, it's in real time. So we can see whatever is happening in the station and the bus stop across an intersection in real time, updating, and then we can also export it out in terms of result. We have XLS, CSV, and JSON. We can specify the timings that we are interested in or all together, and specify what type of data I want to push to what level of detail into that Excel file for me to analyze later on. So extensive tool for you to analyze and visualize your models. This is my email address in case you want to send me any technical questions later on, or you would like to know more about the tool. Please connect with me on LinkedIn, and if you have some time, I recommend that you check my YouTube channel where I usually post most of my webinars and material on. I'll open now the floor for some questions. Please feel free to send them through the chat box. Okay, I've got one question. Can this work efficiently in Nigeria? Yeah, definitely. So the system is actually neutral. So whenever you have the right demand, whenever you have the right existing infrastructure, or at least you have the parameters for your proposed infrastructure, you can definitely make it work in any country worldwide, because the system, again, as I mentioned, uses the stochastic and micro-simulation level methods. So it's very, can be custom made to any city or to any requirement. Okay. Any other questions? By the way, so I was asked level of service. Okay. Just to highlight that in the traffic simulation capabilities of InfraWorks, we only support 2 levels of service, because again, it's the simple part of the simulation. Whereas in the mobility simulation, if you use the mobility simulation for your models, you can specify as many as you like levels of service for both, for the people moving around and for the vehicles as well. So let's suppose in your country you have 6 levels of service for traffic. You can model that, say from 0 to 10 seconds, it's level service A, 10 to 20 level service B, etc., etc. And you can do something similar or totally different for the pedestrians in your model. Okay, does it consume cloud credits? No, it's actually free, so the mobility simulation does not require any cloud credits. So we have some more questions. Software, it's a plugin which, okay. So the mobility simulation runs from within the InfraWorks platform. It's not a different installation. It comes directly, or it's installed directly with InfraWorks. All what you need to do, as I mentioned, you go to the road module, then to the analysis tab, and then from that you pick mobility simulation. Okay, can this work efficiently? Yeah. Okay. Any more questions? Anyway, if you remember anything or if you want to connect with me, please send me an email and let's get on touch as well on LinkedIn. Okay. By the way, a recorded version of this webinar will be shared with you. I believe you're gonna receive an email with a link to download or view the recording. Okay, so feel free to share it with your colleagues, with your friends, as you find suitable. Okay, so that's it for today. Thank you very much for joining us, and see you later.